Hi everybody, today we're going through the circle, exam 2012, paper 2, and here's the question. So here they're giving us two equations of two circles, and they want us to write down the radius and of each of these circles and the center. So we always start with taking the coefficients of the x, coefficients of the y's, and we'll start with circle number 1. So we have minus 6 equals 2g. So g equals minus 3. We're looking for minus g. That equals 3. So I know that the center, the x of the center is 3. And then I do the same for the y. So minus 10 equals 2f. F equals minus 5. And then minus f equals 5. So we have the center is 3, 5. For the radius, we use the formula. It's g squared plus f squared take c. And that equals g squared is just 9, and f squared is 25, and take c, so c is 29, so we get minus 29 root of that. So 9 and 25 is 34, take 29 is 5, so root 5. For the second equation, so again we do the same thing. We divide by 2, we change the sign, and we have the x of the center. And again, the same thing here. It is going to be the same number because we can see it's the same thing. But just for being nice, we'll write it all down. Okay, and for the radius, again, g squared is 1 squared plus f squared is 1 squared again, minus the c. In this case, the c is minus 30. So minus 43, I mean, and that gives us square root of 45. Okay, so we have the two radiuses and the two centers. Then they say prove that the circles are touching. So just to explain about touching, if we have one circle, and then let's say we have a different circle. Let's say we have a different circle here, something like that. So to show that they're touching, our method will be this way. We have our two centers. We'll find the distance between the two centers. Mark that with the letter D. And then we will show that the radius of these two centers, if when we add the radiuses, we get the distance, that means they're touching. If they were overlapping, when we add this, we will get a smaller number than the distance. And if they weren't overlapping at all, if they were far away from each other, we will get that the distance is bigger than r plus r. So in this is one option for touching. So that's if they're touching from externally. But in this question, they didn't tell us are they touching internally or externally. So what is the other option? The other option will be that we have a circle, and then we have inside the circle another circle, something like that, and they're touching internally. So again, we're touching here, and this is they're touching externally, this is touching internally. In this case, we still do the distance between the two centers. So the distance between there and there will be d again. But in this case, you see the distance from here to here is the big radius, and the distance from here to here is the small radius. So in this case, we will get that d has to be equal to r minus r. And we don't know in the question which one it is because they didn't say internally or externally. So we'll just do the distance first, and then we will see does it add up to the radiuses or is it the difference between the radiuses? And then we will be able to say what we are. So I'm going to do the distance. So the distance is just the distance between the 2 points. So between these 2 points here, 3, 5, and 1, 1. Take the x's, so 3 take 1 to be squared. Take the y's, 5 take 1 to be squared. And it's 2 squared is 4, and 4 squared is 16, so that's square root of 20. Square root of 20, if you do it in the calculator, or if you do it in your head, it's 2 square root of 5. And then we'll do we know the radiuses, so the little radius is square root of 5, and the bigger radius was square root of 45. And I'll just do this as also 3 square root of 5. So now when I look at my two radiuses, I'm just going to think, are these, if I add them, do I get 2 square root of 5 or do I take them? Of course, we can see it's taking. So r minus r equals 3 square root of 5 take square root of 5 equals 2 square root of 5. And that is actually the d. So it's not just that we know that they're touching, we also know that they're touching internally. So if they ask how are they touching, we will be saying it internally. We didn't know at the beginning of the question which one it is because they didn't tell us. Okay, so we'll move to the next question. They're saying verify, the next part, sorry. So they're saying verify that 4, 7 is a point that they have in common. So because they're giving the point, all we have to do is sub the point in both of the circles and show that it is on both of the circles. If it's on both of the circles, of course, that is the point of contact. And I'm subbing in my 0.47. So 4 squared plus 7 squared minus 6 times 4 minus 10 times 7 plus 20 equals, and I calculate that, and that's 16 and 49 minus 24 minus 70 plus 20, and I calculate it and it comes out 0. So it's on the circle. And then I do the same for the other equation. So the other circle is x squared plus y squared minus 2x minus 2y minus 43 equals 0. And again, we sub it into there, and we get 4 squared plus 7 squared minus 2 times 4 minus 2 times 7 minus 43. And we calculate those numbers. 16, 49 minus 8 minus 14 minus 43 comes out 0. We're very happy. It's on the circle. And therefore, because it's on both circles, we know it's the point of intersection between them. Find the equation of the common tangent. So now we know that the 0.47 is the point that we're going to use as x1, y1, because that's the common tangent. So what we're looking for now is the line there. So we have the 0.47, and what we're missing is the slope. So again, we're going to use the slope of the radiuses, that slope there, and then because we know it's 90 degrees, we can invert it and get the slope of our line. So in order to do that, we need the 2 points of the radiuses, the 2 centers, and remember there were 1, 1 and 3, 5. When I didn't remember, I just checked. 1, 1 and 3, 5. So I'll find the slope of these 2 points, the line that these 2 points are on. Take the y's, so y minus 5, overtake the x's. So it's minus 4 over minus 2, which is a 2. Therefore, our slope is 1 over that minus 1 over m. We just change the sign. So it's 1 over 2 and stick a minus there. So that's our slope. And then we put them all together. So it's y minus 7 equals our slope, x minus 4. So y minus 7 equals minus x over 2 plus 2. And I can add 7 to both sides. So y equals minus x over 2 plus 9. And if you want it in the format ax plus by plus, just multiply everything by 2 and rearrange, and you'll get it in the other format. But this is